This question asked in IIT-JAM 2024. Consider the wave function psi is equal to e power I into kx, this is actually psi, e power exponential, right, e power I kx plus e power minus I kx, the complex conjugate, that is psi star of x, is given us. Okay, so is given, n is the normalization constant and I is equal to square root of minus 1. All the data are given. So we need to find out this complex conjugate of psi. Okay, so how to do this? What is the answer? Listen, let me discuss here. For this question, see, the given wave function is psi of x is given, psi of x equal to e power I kx, exp means exponential, okay, we can write it as e power I kx plus e power minus I kx. This is the function given. Now we should take the complex conjugate of the function. So what is complex conjugate? Psi star of x. Okay, complex conjugate is nothing but, see, taking complex conjugate is nothing but changing the sign of the complex quantity, that is I. If you have plus I, you put minus I. In the place of minus I, you put plus I. So what we get is e power minus I kx, and here keep this sign, you should keep it as such. E power, and in the place of minus I, we put plus I kx. Change the sign of the iota term, iota, okay, I value. Right? This is the complex conjugate. Right? This is the complex conjugate. See, complex conjugate is nothing but psi, right? We are getting the same function. Okay? Yes, take it. If you normalize the function, you will get some normalization constant. Let me take this n. So n into e power minus I kx plus e power plus I kx. Yes, this is the complex conjugate of the given function. Okay, so the correct option for this question is option C. Option C. Okay, this becomes plus e power I kx and this is e power minus I kx. I wrote e power minus I kx in the first place. You can, since we are having plus sign, you can write e power I plus I kx first and e power minus I kx next. Okay, so the correct option for this question is option C. Right? Take it. This is a question asked, a quantum chemistry question asked in 2023 IIT-JAM. The question is this: the system with the lowest 0 point energy when it is confined to a one-dimensional box of length L is 1D box of length L is given. Now different particles are given: electron, proton, helium atom, hydrogen atom. Now among these particles, which particle will give lowest 0 point energy if it is confined in one-dimensional box of length L? Yes, try to answer this question. See, for this question, what is the answer? This is very simple actually. You know very well, for 1D box, 0 point energy is nothing but the lowest energy possible. Okay, that is the ground state energy. So 0, let me write shortly, ZTE, meaning 0 point energy. 0 point energy is nothing but the ground state energy of particle in 1D box, which is given as h square by 8mL square. Quantum number, actually we should put n square. Okay, n value is 1, so it is 1 square. Right? And this is called the 0 point energy. Now, see, 0 point energy is E1, it is inversely proportional to mass. Correct? I have mass here, it is inversely proportional to mass. So, the particle having high mass supposed to have least 0 point energy. So, which is having lowest 0 point energy? You should see among the four which is having higher mass. You know very well, electron has the lowest mass, right? Mass of electron. Let me write here, mass of electron is lowest. Then mass of a proton. Okay, in the case of hydrogen atom, right? In the case of hydrogen atom, we have a proton and an electron which is slightly heavier than mass of proton, slightly heavier. And if you go to helium atom, which consists of 2 proton, 2 neutron and 2 electron, yes, which is heavier among the 4. So the particle having heavier mass should have lowest 0 point energy. Should have low 0 point energy. So among the 4, the one having lowest energy is helium atom. So the correct option for this question is option C. Okay, you know very well, for particle in 1D box, this is general formula for energy, right? En equal to n square h square by 8ml square. This is general formula for energy. If we put n equal to 1, we will get the 0 point energy. What is 0 point energy? It is the lowest possible energy in quantum mechanics, through quantum mechanics. Right? So the correct option for this question is option C. Right? Take. This question appeared in 2022 IIT-JAM. The potential for a particle in a 1D box is given as potential is given as 0 if x is between 0 to L. This is normal box, correct? X is between 0 to L, right? Potential energy is 0 and potential energy is infinite elsewhere. Yes, this is normal 1D box. Now the location of the internal node of the eigenfunction psi of x when n greater than or equal to 2r. Okay, the location of the internal nodes of the eigenfunction psi of x where n is greater than or equal to 2r. Given m is an integer such that m should be in between 0 to n. 0 to n. Okay. For a particle in 1D box, you know very well the ground state wave function. Let me draw all the wave functions here. Okay, first I will take ground state n equal to 1. I am plotting wave functions, right? Wave functions along the axis. So for ground state, the wave function is supposed to be like this. Okay, in the ground state, when n is equal to 1, there is no node. But when you come to n equal to 2, right? Yes, you know very well, there is a node at the middle of the box. There is a node. Okay, so where is the location of the node? Location of the node? Location of the, yes, you are right. Location of the node is equal to L by 2 middle of the box. Right, then if you go to n is equal to 3, there should be 2 nodes. Okay, there should be 2 nodes. I will draw the nodes here. 1, then 2. It goes like this. Right, when n is equal to 3, there are 2 nodes. Okay, here we have 1 node and here we have another node. What is the location? It is almost 1 by 4 and 3L by 4.
L by 4, 3 by
yes.
4.
Yeah, that is the location. Okay, we call them as internal nodes. Right? So now, if you analyze with the formula, listen. So number of location of the internal node. First, let's start with n equal to 2. When n is equal to 2, I have a node at the middle of the box. Now, middle of the box means L by 2. So location of the node is x is equal to L by 2. X is equal to L by 2. Right? Therefore, I just go through the formula in which one I'll get the answer as L by 2. Listen. Listen. M should be an integer. It's given clearly. M should be an integer. And n is a quantum number that is also integer. Okay. Therefore, the numerator and denominator should be integers. If you take first option, I have m plus half. If you take m plus 1, we'll get fractional. So, this cannot be the answer. Okay, then if you come to here, yes, this is possible because m is an integer, n also integer. When if you take n is equal to 2, if n is equal to, m should be less than 2 and m is an integer, therefore less than 2 integer is 1. Therefore it should be 1 by 2. Yes, this option exactly matches. Okay, so try to remember this formula. To find internal nodes, you can use this formula directly, m by n into L. M by n into L, where m should be greater than 0 and less than n. Remember this, very, very important. Right? Suppose if you go to n equal to 3, what are the locations of nodes? Yes, if you take n equal to 3, n value is 3. Right? And what about the m value? Listen, m value should be an integer. Okay, m value should be an integer and it should be less than 3. So it should be either 2 by 3 or 1 by 3. Okay, if you put 1 by 3, yes, you take the, you take the total length as 1. So the one part, this is another part, this is another part. So you just equally divide this into 3 parts. So this part, this position is at 1 by 3 and this position is at 2 by 3. Okay, take it. So try to remember this formula. This formula will give you the position of the node, internal node. Position of the internal node, right? For any levels above n equal to 1. Any level above n equal to 1, you can use this formula. Okay, take it. Yeah, this question appeared in 2020 IIT-JAM. Psi is a function of x, y, z coordinates. Describes the wave function of a particle. So psi is the wave function of a particle. The probability of finding the particle between x and x plus dx, comma y and y plus dy, and z and z plus dz can be expressed as. How to express the probability? Yes, try to answer this question. Yeah. So here, wave function is given. It depends on 3 coordinates x, y, z. And the question asked here is the probability of finding the particle between x and x plus dx, y and y plus dy, and z and z plus dz. Okay, how to do that? Listen. Very simple. Listen, they are asking probability between x and x plus dx, which means they are asking in the distance dx, what is the probability? Similarly, y and y plus dy, which means they are asking probability in the range dy. Similarly, z and z plus dz, they are asking probability in this range. That means dx into dy into dz will give you a small volume, right? Small volume, right? Let this distance be dx, this distance be dy, and this distance be dz. X length, y length, and z length are dx, dy, and dz. Okay, if you multiply these 3, you will get what is called d tau. You might have heard about this. D tau. D tau is nothing but the small volume element. Now what is the probability of finding the particle in this small volume element? It is nothing but, listen, take the complex conjugate of the function psi star x, y, z into psi x, y, z. Psi into psi star or psi star psi into this d tau. Okay, but in the option, instead of d tau, it is given like dx into dy into dz, so you can use this. So this will give you probability of finding the particle in this region or in this volume element. Instead of writing psi star psi, you can also write in this manner. That is square modulus, right? Square modulus of the function x, y, z, right? Into dx into dy into dz, right? Will give you probability of finding the particle in this location, in the small volume element. Okay, so if you analyze the options, right? If you analyze the options, yes, listen, option A is wrong. Why? It gives you probability at the point x, y, z. It is called probability density. It is called probability density at a point, at a particular point x, y, z. Whereas this gives you, second one gives you probability in the small volume element d tau. Okay, and third option also will give you the same probability in the small volume element d tau. Right? What about the fourth one? Fourth one, listen, they are integrating from minus infinity to plus infinity. Minus infinity for dx, along dx, then dy, then dz. This will give you total probability. Okay, total probability of finding the particle from infinity distance, minus infinity to plus infinity along x-axis, minus infinity plus infinity along y-axis, minus infinity plus infinity along z-axis. Okay, so this becomes the entire universe, right? So this is called total probability. Total probability is 1, but they are not asking total probability. They are asking probability in this range. Okay, therefore the correct options are B and C. You know very well, in JAM examination, multiple options are also possible. So for this question, the correct options are B and C. Right? B and C. Yeah. So what's the question was? This question appeared in JAM 2017. For a particle in 1D box of length L, with the potential energy is 0 for, listen, it is above 0 and below L. Yes, it is a perfect 1D box. Perfect 1D box. The, in between 0 and L, potential energy is 0. Okay, good. And potential energy is infinite beyond L and beyond 0. Yes, that's also is a correct perfect 1D box. An acceptable wave function consistent with the boundary condition is, they are asking accepted wave function, right? Yes, just go through all the options and try to tell me which is the acceptable wave function. The question, see here, the box length is actually 0 to L. Okay, let me give you this information. You know very well, a particle in 1D box, for 1D box problem, you know very well, if a particle move along x-axis, okay, and we keep potential barriers, so that particle is confined to move only within the box, and here x is equal to 0, here x is equal to L, so that the length of the box is L. And what is given is potential energy is 0 between 0 to L, meaning inside the box it is 0, and the potential energy is infinite everywhere or elsewhere. That is beyond x is equal to L and beyond x less than 0. Okay, potential is infinite. In this case, listen, if you solve the Schrodinger equation, we get a general solution for wave function. What is that? Psi n of x is equal to a normalization constant square root of 2 by, yes, sine into n pi by L into x. This is the wave function. And what is the energy formula? En equal to n square h square over 8 ml square. Yeah, so we know the wave function, we know the energy, very good. But if you see the options, see in the question they are asking only wave function. So we need wave function containing psi n pi by L into x. Okay, but in option A, cos function is given. It is not possible because this is normal 1D box, 0 to L. For boundary condition 0 to L, okay, you will never get cos function. We get only sine function. Then, in option B, x and x plus x square is there. Is it acceptable or not? Because they are asking only acceptable wave function. What to do? You just use the boundary condition. Listen, what is the boundary? X equal to 0. See, the boundary is x equal to 0 and x equal to L. You know very well, at the boundary, wave function should vanish. Okay, if you put x equal to 0 here, I'll get 0 plus 0. Yes, at x equal to 0, wave function vanish. Very good. What about at x equal to L? If you put x equal to L, will it become 0? You put here L plus L square. I'll get some value. It is not equal to 0. So that means this is not an acceptable wave function. This is not acceptable. Okay. Then what about option C? In option C, listen. At x equal to 0, what will happen? See? At x is equal to 0. If I put x equal to 0 here, yes, I have x cube. So if I put x 0, the entire wave function becomes 0. So wave function becomes 0. What happened at x equal to L? That is the other limit. Other terminus, right? Now if you put x equal to L here, L minus L is 0, again the wave function becomes 0. Yes, this wave function satisfies the boundary condition. So the correct option is option C. What about option D? In option D, listen, d by sine is given. If you bring this sine to the numerator, you will get sine inverse. You know very well, for box with the boundary condition x equal to 0 and x equal to L, wave function should have sine n pi by L in the numerator. But if you bring this sine to the numerator, you will get sine inverse. That is not allowed. So this is not an acceptable function. So among the four, the only acceptable function is option C. Right? Take two. So this question appeared in IIT-JAM 2016. The question is this: the maximum of a function a into e power minus ax square, where a is greater than 0, small a also greater than 0. So that means a is positive, big A also positive, small a also positive, both are positive. Okay, the maximum of the function, see this function will give you a maximum at one particular x value. At what x value you will get that maximum? This is what we need to find out. Going to do, listen, to find maximum or minimum, you differentiate the given function, okay, 1 times and put the value equal to 0. So let me take the given function as psi. So psi is equal to a into e power minus ax square. Okay. Now I will differentiate this function once. So d psi by, I am differentiating with respect to x, because function depends only on x. Right. So what I am going to do, keep the a as such. Differential of e exponential term will give you the same thing. Then if you differentiate the power term, you will get minus 2ax. Okay. So this is the first derivative. Now at the maximum, right? At the maximum, d psi by dx, also called slope, it should be 0. So we should put this value equal to 0. So a into e power minus ax square, okay, minus, I'll bring minus in front, 2ax equal to 0. Right? Now listen carefully, what will be the value of x? Right? Yes. If you put x equal to 0 here, right, or bring all the term to the right hand side, keep only x here. So 0 by anything is 0. So x is equal to 0. Right? So the only possible value at which you get maximum is at x equal to 0. Okay. What I did here, I kept this x as such and brought all the term to the right hand side. Everything in multiplication. So if you bring it to the right hand side, 0 by something is 0. So when x is equal to 0, you will get maximum. Okay. What's the other possibility? Here we have x square, right? So keep this term as such, e power minus ax square as such, bring all the term to the right hand side, that becomes 0. Now, e power minus ax square 0. What value of x will make e power minus term 0? It is very simple. X should be plus infinity or minus infinity. Correct? If you put plus infinity or minus infinity, e power minus infinity, then x can be plus or minus, but I have x square here. So whether you put plus infinity or minus infinity, if you take square, it will become positive. But I have minus sign in front. Therefore, listen, this becomes 0 only at x is equal to infinity. It may be plus infinity or minus infinity, whatever it is. So at x equal to 0, you will get maximum. Then at x is equal to infinity, we will get maximum. Okay, but for acceptable wave function, wave function should vanish at x equal to infinity. Okay, right? Wave function should vanish. Therefore, you won't get maximum at x equal to plus infinity or minus infinity. We know very well. At x equal to plus infinity, right here, when x approaches plus infinity or minus infinity, wave function should approach the value of 0. That wave function should vanish. Okay, it cannot be maximum. So, though mathematically we get a maximum at x equal to infinity, mathematically, but for a wave function, okay, this is not allowed. So, the only allowed condition is x equal to 0. At x equal to 0, you will get the maximum. Okay, so the correct option for this question is option A. So this is our next question. If x operator is equal to x and the px operator, this is not x into and the px operator is h by 2 pi I d by dx, linear momentum operator. You know very well x component. This is x component of linear momentum operator. Then the value or values of px x comma minus x comma px's. Okay, they are asking commutator value. Yes, try to answer this. I'll just show you. See, they are asking px operator into x operator minus x into px. Okay, now you take some function f, apply this operator on the function. Okay, we'll find out the values, right? So what to do? Px operator into x acting on the function f, bring f here, then minus, bring f here, x into px of f. Okay, what is px operator is given here? H by 2 pi I into d by dx. What is x operator? X operator is nothing but x. So x into f here, minus here, x into px is h by 2 pi I d by dx of the function f. Okay, now what I am going to do, I will use UDV method here. I will take h by 2 pi is common. H by 2 pi I, I will take this common. So I have d by dx. So UV method you apply. So first I will take x as such, differentiate v. So you will get df by dx. Plus, then keep f as such, differentiate x. If you differentiate x, you get 1. Minus h by 2 pi I have taken common. So I will get x into df by dx. Okay, differential of f is df by dx. Now, see, this is plus x into d by dx. This is minus, they cancel each other. So we get h by 2 pi I into the same function. So I applied this operator on the function. I am getting the same function, and this is nothing but the eigenvalue. Okay, they are asking actually eigenvalue, but instead of eigenvalue, they are asking simply value. Okay, so this value is nothing but h by 2 pi I. Now we'll compare the options. Listen, you know very well h by 2 pi.
H cross.
Yeah, you know very good.
H cross by
yes,
I.
h by 2 pi I is nothing but h cross by I. H cross by I, yes, in option A I have h cross by I. Then you multiply numerator and denominator by I. If you multiply numerator and denominator by I, what will you get? H cross I by I square. What is I square?
Minus
1. So we can write this minus h cross into I. Yes, this is also correct. Minus I into h cross. So option A correct, option B correct. Option C is given 0, it is not possible. Option D, h cross is given in the denominator, which is not possible. So the correct options are A and B. Okay, yes, take it. Yes, this question appeared in IIT-JAM 2008. If the electron were spin 3 by 2 particle instead of spin 1 by 2, then the number of electrons that can be accommodated in a level R. Yes. Listen, suppose if spin is, see, you know, if spin is half for electron, then there are two possibilities, right? What are they? Ms plus half, Ms minus half. Only two possibilities. Therefore, we can put only two electrons in a level. Okay, in an energy level. Okay, in a level. Suppose instead of spin half, if electron has spin value of plus 3 by 2, I'm sorry, not plus 2, just 3 by 2. If spin is 3 by 2, then how many possible values of Ms we get? Ms plus 3 by 2, Ms equal to plus 3 by 2, Ms equal to minus 1, so we will get 1 by 2, Ms equal to minus 1 by 2, and I don't have space here, I'll get here, Ms equal to minus 3 by 2. So 1, 2, 3, 4 values are possible. Therefore, 4 electrons, okay, can be accommodated in a level. 4 electrons can be accommodated in a level. I have 4 possible Ms values. Okay, take it. So the correct option for this question is you can accommodate 4 electrons in a level, right? For a particle in cubical box, the total number of quantum numbers needed to specify its state are. This question appeared in IIT-JAM 2008. Listen, it's a very simple question, you know very well. Cubical box means 3-dimensional box. Okay. Cubical box means 3-dimensional. For each dimension, you need one quantum number. So there are 3 dimensions, so you require 3 quantum numbers. We represent them as nx, ny and nz. So we get 3. We need 3 quantum numbers to specify the state. Okay, state we use wave function psi symbol. Okay, so you need 3 quantum numbers nx, ny and nz to represent the state of a particle. Okay, in a cubical box. So you need 3 quantum numbers. The correct option is C. Right? Yeah. The normalization constant A for the wave function y is equal to A into e power im phi, where phi, the limit for phi is 0 to 2 pi. We need to find out the normalization constant, and this question appeared in JAM 2007. Right? So we need to find out normalization constant, and the wave function is given as y is equal to, what's the wave function given? Y is equal to A into e power I m phi. To find normalization constant, what we should do is that you have to normalize it. Okay. So let us take this A as the normalization constant. Right? To find A, what to do? You know very well, integral. The limit is given 0 to 2 pi. Integral y star into y, wave function and its complex conjugate, into the variable is phi here, d phi, that should be equal to 1 in this interval. Okay, so this is the normalization condition. This is the normalization condition. Now let me use here integral 0 to 2 pi. Observe carefully. What is y? Y is the given function. What is given? A into e power I m phi. Then what is y star? Y star is complex conjugate. So A, listen, assume that normalization constant is not a imaginary number, it's a real number. Okay. So e power, in the place of plus im phi, you should put minus im phi. Okay. Into d phi, that should be equal to 1. So here I have A, here I have A into A is A square, integral 0 to 2 pi. Now e power minus im phi into e power plus im phi. If you multiply, you should add the power. So you will get e power 0 into d phi equal to 1. What is e power 0? E power 0 is 1. So we get A square into integral 0 to 2 pi d phi equal to 1. If you integrate d phi, integral dx is x, right? So integral d phi is phi, upper limit 2 pi, lower limit 0. If you substitute, let me write here. A square into, you will get phi, upper limit 2 pi, so you will get 2 pi, lower limit is 0, you need not write. Okay. Lower limit is 0, so you need not write. So A square into 2 pi equal to 1, or A square equal to 1 by 2 pi, or A is equal to, actually we should put plus or minus, but by convention we take only positive value. So plus 1 by square root of 2 pi. Yes, this is the normalization constant for the function. For this function, y is equal to a power em phi. Okay, if this function, right, then for this function to be normalized in this interval, a should have the value 1 by square root of 2 pi. So the correct option is option A. Okay, take. This question appeared in IIT-JAM 2006. The wavelength for a particle moving in a ring, yes, it is given ring, is 2 pi power minus half, 1 by, there is 1 by root of 2 pi, e power 2i phi, where phi is the polar angle. The probability of finding the particle in a small interval d phi when the value of phi is pi by 2 is. Okay, so they are asking probability of finding the particle in a small interval d phi. Okay, yes, how to do this? So in the question it is wrong, it is typed wrongly. It is not wavelength, it is actually wave function. Wave function for a particle moving in a ring is this. We need to find out the probability. Yes. So result, for a particle on a ring, this is the general wave function formula. Okay, actually here we should put some quantum number m, but this is for some state. Okay, so some value of m is given, m equal to 2 in this case, right? And now we should find out the probability of finding the particle in a small interval dv when the value of phi is pi by 2. Okay, now listen, this is the probability formula. Probability in the interval dv. So what is psi? We know that psi is nothing but 1 by square root of 2 pi into e power 2 I phi. Okay, into what is psi star? Psi star is 1 by square root of 2 pi e power, instead of plus I you put minus I, so minus 2 I phi into d phi. Okay, so 1 by root 2 pi, 1 by root 2 pi, if you multiply you get 1 by 2 pi into, if you multiply these two you get e power 0 into d phi. Okay, so we get d phi by 2 pi, d phi by 2 pi. Okay, take it. So the correct option for this question is option D, d phi by 2 pi. This is the method you should follow. Okay, they are asking probability in the small interval d phi. So use this formula and simplify it, you will get the probability directly. Okay, take it. This question appeared in IIT-JAM 2024 latest question paper, this year question paper. The function e power minus 2 into x minus 1 whole square attains a maximum at x equal to, at what value of x this function will attain maximum, rounded off to the nearest integer. Okay, check. So how to answer this question? It's very simple. They are asking maximum, right? And function is given. So let me take the function as psi. See, what is the given function? The given function is this. Let me take the function as psi. So psi is equal to e power minus 2 into x minus 1 the whole square, x minus 1 square. And this function attains maximum at what value of x? So to find maximum, what you have to do? Differentiate this. Differentiate psi with respect to the coordinate. So we have the coordinate x here. So differentiate with respect to x. E power, if you differentiate, you will get the same thing. E power minus 2 into x minus 1 whole square. Okay, yeah. So let me do one more step here before differentiation. Let me simplify this so that differentiation become easy. So I will keep this minus 2 as such. What is x minus 1 whole square? A square plus b square minus 2a. Correct? Or psi is equal to, just multiply this by minus 2, we will get minus 2x square plus 4x minus 2. I just wrote in an ordered manner. So this is the function. Now we differentiate. So differentiate this with respect to x. What we get is, if you do differentiation of e power term, you write the e power term once as such. Then take the powers. Minus 2x square, if you differentiate, you will get minus 4x.
Minus 4x
yes.
plus 4.
4x plus, this is 4. So minus 4x plus 4, okay. And now put this value equal to 0 to get maximum, right? Right, to find, or at the maximum, at the maximum, d psi by dx equal to 0. So which means e power minus 2x square plus 4x minus 2 into, I'll take 4 as common here, 4 into minus x plus 1 equal to 0. Okay, so either this quantity should be 0 or this quantity should be 0. Okay, here you bring the 4 to the right hand side, 0 by 4 is 0 only. So for this function to be 0, either this should be 0 or this should be 0. First I will make this 0. So I will make minus x plus 1 equal to 0 or x is equal to 1. So at x is equal to 1, yes, the function will give you maximum. What is the other chance? The other chance is this quantity can be 0, but you know very well, for this to be 0, x should be plus infinity or minus infinity. X should be infinity. Okay, x should be infinity, right? And you know very well, when x approach plus infinity or minus infinity, wave function becomes 0. So maximum is not possible there. Therefore, maximum is possible only at x equal to 1. Okay, for this function. Alright, take it. So the correct answer for this question is x is equal to 1. Right? Take it. So for this question, the correct answer is x is equal to 1. Right? This is the idea. What you have to do? First, simplify the given function and take the function in a simplified form and then differentiate this, because you need to find out maximum. You know very well at the maximum or minimum, first differential of the function should be 0. So differentiate the wave function with respect to x and put the value equal to 0. Right? Now if you put the value equal to 0, you will get some x value. That x value will give the maximum. So what are the x values possible? X equal to 1 or x is equal to plus infinity or minus infinity. But we know very well, when x approaches plus infinity or minus infinity, wave function becomes 0. Okay, so when wave function is 0, what is the meaning for maximum, right? So maximum is not possible here. So the only possible value where maximum exists is x equal to 1, right? This question also appeared in 2024 JAM. The question is this: the magnitude of energy difference between the energy levels n equal to 3 and n equal to 2 of a quantum particle of mass m in a box of length L. Box of length L means 1D box. And the energy formula is given. What's the value of x?
5, sir.
Okay, listen. Here they are asking energy difference. Energy difference between n equal to n equal 3. Adjacent, right? And you know very well, for 1D box, for one-dimensional box, right, the delta E between adjacent level is equal to 2n plus 1 times h square by 8ml square. See here, I have h square by 8ml square here. Therefore, the x should be equal to 2n plus 1. Right? What is n? Which n we should put? We should put the lower value of n. So I have n equal to 3 and n equal to 2. The lower value is n equal to 2. So put 2 here. So 2 into 2 plus 1. Yes, I will get the answer as 5. So for this question, the correct option is